Ladies and gentlemen, good morning. We appreciate the opportunity to give the presentation about assessing load characteristic and performance of Zoom and other video conferencing platforms to you. My name is Hao Zhong, and my group members are Yu Zhuoli, Junyi Yang, Zhang Haolu, and Yunqing Huang. Before we delve into the heart of our presentation, firstly, please allow me to introduce the components of our speech of today. Our presentation consists of 7 parts. Firstly, we will give a brief introduction to the literature review. Secondly, Junyi Yang will explain our research question according to the topic. Then, Yuzhuli will give some details of prior work. After that, Yunqing Huang will summarize the research gaps. Finally, Zhang Haolu will give a conclusion to the literature review and compare our context with the work done by AI. The references are attached to the last page. We encourage you to ask questions and share insight with us. So firstly, please allow me to give a brief introduction to our topic to you. As we all know, the COVID-19 pandemic brought unprecedented changes to our daily lives. Lockdowns, travel restrictions, and a major shift towards remote work and online education became the norm. As a result, video conferencing platforms, especially Zoom, became crucial to our daily interactions. With this surge in users, especially within educational campuses, these platforms started encouraging challenges tied to network performance. How do these platforms cope, and are there noticeable differences in their performances? To address these questions, our literature review delves deep into existing studies that crucially examine performance and load characteristics of these platforms during the pandemic era. Understanding this characteristic is important. It is not only aids institutions in making informed decisions regarding network infrastructure, but also helps software developers enhance their product for optimal performance.
Hello everyone, my name is Junyi Yang. Building upon our introduction, let's dive into the core of our investigation. How did Zoom and similar tools fare on campus network amid the COVID-19 storm? We have honored in on Zoom's load and performance, set against the backdrop of campus network, drawing insight from real-time usage during the pandemic. Our object is clear, to get their quality and usability. As we progress to peer work, keep in mind our ultimate goal to enhance users' experience in these tools. Continuing from our research question, we will deep into the analysis of Zoom's performance and load characteristics, especially for its heightened usage during the pandemic. We have all experienced, or at least heard of, the rapid user adoption of Zoom and other video conferencing platforms during the pandemic. With this usage came challenges. Audio lags, video hiccups, and unstable message became an all too familiar part of our virtual lives. To understand why, researchers employed passive management techniques. One striking discovery was Zoom's adaptability. With only 2 participants, it employed a peer-to-peer mode. But as more participants joined, it shifted to a server mode. This type of mode influences its performance in visual network environment. Going deeper, researchers even investigate Zoom's performance at the package level. We have 2 results. First, Zoom's face efficiency challenges, especially on network with congestion or data loss. Secondly, the complex interaction of Zoom's multi-layer protocols. And if we were condensed to the core issue, it resolved around this problem, the trade-off between the demand of Zoom's services and its ability to supply them. As we move on, let's keep these fundamental understandings in mind. They will get us as we benchmark Zoom against its competitor in our next segment. And my teammate Yu Zhuoli will continue on this part. Thank you for listening.
Hi, I'm Yuli. As we continue to look through the prior work, in the first section, we delve into the streaming lag range observed in different platforms when used in the US. It was noted that Zoom maintains a fluctuation rate between 20 to 50 milliseconds, but having a higher lower limit compared to WebEx, which stands at 10 milliseconds. Despite the high overall streaming-like values, Google Meet stands out with its distributed service endpoints, as shown in the figure. What is more advanced with Zoom and WebEx is that no matter where the user is in the meeting, that is, the US or other parts of the world, the user's streaming-like range of Meet doesn't fluctuate very much. And moving on to the round-trip time, or RTT, Zoom and WebEx showcase similar performance. However, Google Meet exhibited uniform RTTs across all clients, also thanks to its distributed service endpoints. And for the CPU usage, where Google Meet takes the lead with 50% usage, attribute to the small preview display in full screen mode. And Zoom, on the other hand, utilized about 12% of the CPU to cache additional video streams, enhancing the user experience when toggling between different views. We also explored bandwidth consumption and other video conferencing platforms like Microsoft Teams. Our analysis, derived from various studies, paints a comprehensive picture of the performance of these platforms, providing a pathway for future optimizations and improvements in user experience.
My name is Huang Ting, and I will introduce the research gap. When discussing the performance and load characteristics of video conferencing tools such as Zoom, existing literature provides us with a solid foundation. But there are still some areas that require further research. Firstly, current studies primarily concentrate on performance metrics like latency, bandwidth consumption, and round-trip time. However, there is a lack of comprehensive research that delves into other critical performance metrics such as jitter, frame rate, and packet loss, which are essential for quantitatively describing the quality of the user experience. Secondly, we studies have compared Zoom's performance to other popular platforms. There is still a gap in the literature concerning cross-platform optimization. We believe that leveraging the strengths of different platforms is an effective method to enhance the user experience. Therefore, further research should adopt a more comprehensive approach, including expanding the range of performance metrics analyzed and exploring the relatively uncharted territory of cross-platform optimization. Furthermore, a focus on quantitative metrics that accurately describe the user experience can pave the way for more nuanced insights into the performance of Zoom and other video conferencing tools, thereby guiding the development of more optimized solutions for video conferencing in campus networks.
Hi everyone, I'm Zhang Hanglu and I will be responsible for the summary section. In conclusion, the literature review presented here has provided a comprehensive analysis of the performance and load characteristics of video conferencing tools, with a particular focus on campus networks during the COVID-19 pandemic. The current literature has limitations, as it primarily concentrates on a restricted side of performance metrics, leaving crucial aspects like jitter, frame rate, and packet loss relatively unexplored. Furthermore, there is a dearth of research in the domain of cross-platform optimization. However, it has offered valuable insights into the challenges faced by users, and one intriguing suggestion that emerged from our review is the possibility of Zoom learning from Meet's distributed service endpoint to enhance the global user experience. As video conferencing tools continue to play a crucial role in the education sector and beyond, it is imperative that we explore the uncharted territories highlighted in this review. This ongoing research will not only enrich academic discourse but also contribute to the development of more efficient and user-friendly video conferencing solutions for campus networks. Ultimately, this will lead to smoother and more productive remote learning and working environments in post-pandemic era. Now, let's briefly compare the findings of this literature review with the capabilities and limitations of AI in handling such tasks. In summary, AI needs clear formatting guidance for standardized results and struggles with logical coherence and relevance in summarizing complex literature. While AI can certainly aid in data analysis and initial literature screening, it cannot replace the critical thinking and nuanced understanding that human researchers bring to the table. The review presented here exemplifies the need for human expertise in synthesizing and drawing meaningful conclusions from academic literature. Here are our references. Thank you for watching.